Hi guys, welcome to this integrated course on descriptive statistics. Here we'll be focusing mainly on the descriptive side. So what is descriptive statistics and what do we do with it? Descriptive statistics is about describing and showing data. Here we describe data and show it without sampling and making inferences to the population. This is the key distinction. We can use descriptive statistics in a population or in a sample. We just don't infer from one to the other. Okay, so what is it that we study? We study the data by describing it and by showing it with graphs. Let's start with an example. We have 11 people in a class and collected all the exam grades. A data point is one individual grade. A data set is all the grades collected. Before doing anything else, always sort your data set from the smallest to the largest. To categorize the data, we have three measures: central tendency, dispersion, and shape. Note that each measure is also called statistics when it's from the sample side. Let's start with central tendency. Central tendency is a single value that represents the center of the data set. There are three measures of central tendency: mean, median, and mode. Just to reiterate, you may also hear this referred to as mean statistics, median statistics, and mode statistics, because you are looking at this from the sample side. From now on, we will leave this statistics term, but keep that in mind if you see it. Let's start with an example. The mean is obtained by 1. Summing all data points, and 2. Dividing it by the total number of data points, or n. There are other ways of calculating the mean, but we will stick to this one. The next one is mode. Mode is the data point that has the highest frequency in the data set above 1. Here are some examples. If we have 2, 4, 4, and 5, the mode is 4. 2, 4, 4, 5, 5, 6, the mode is 4 and 5. We say that the data set is bimodal. Same thing for this next one. The mode is 4, 5, and 6. We say that the data set is trimodal or multimodal. And for this next one, here the mode is 7. Remember, it is the highest frequency count that matters. So in our example, the mode is 85 as it appears twice, and the others only appear once. So this is the only one that counts. The next measure is the median. Median is the value that separates the data set in half. To calculate it, we need an index. If it is odd, the median is the number in the center. If it is even, we sum the middle indexes and divide by 2. This will point to the correct x value. Both cases are easier to do with smaller data sets, but with larger ones, we need a formula to do these. So start using the formulas, get used to these, and in time, you'll find it much easier. The next set of measures are about dispersion. These quantify how the data points are scattered. Here's an example. Look at the following three graphs. They are all centered about 50%, but the dispersion is different. The green one is much wider than the blue one. If these were investment funds, at the end of the year, they all produced the same return of 50%. But throughout the year, the green one varied much more than the blue one. These are the measures of dispersion. We will go through each one with examples with our data set. The first step is to have the data set arranged by order. I already told you this, but this is important because sometimes in exams they will show you the data, but it's unordered. So that's the first step. So remember, from the smallest to the largest number. Same as before, we need our index. So our minimum statistics is 72, our maximum statistics is 92. Our range statistics is the difference between both, so 20. Okay, so now we are done with the minimum, maximum, and range. Let's look at the quartiles and the interquartile range. Quartiles means dividing the data set into 4 equal parts, in a specific case with 3 divisions. Each one is a quartile. You can do quantiles and all different types of subdivisions, Let's just focus on this one. So the first quartile is at 25%, the second quartile is at the middle at 50%, and the third quartile is at 75%. The second quartile is a medium. It is also a measure of central tendency and is also a measure of dispersion because it is the second quartile as well. To find the quartiles, we will use the same rules when finding the medium. Let's calculate an example. It is even, so the medium is 80. Quartile 1 is 70 and quartile 3 is 90. So the IQR is 20. To calculate outliers, we use a technique called 2K fences. The idea is any data points above the upper fence are outliers, and any data points below the lower fence are outliers. For the lower fence, use the minus sign, and for the upper fence, use the plus sign. So in this specific case, we have 30% as a data point, so 30%, remember the grade, is an outlier because it is less than 40%. This means that the student that had 30% on the exam did much worse than anyone else. For the upper fence, remember same formula but with a plus now, anything above is an outlier. And obviously we have nothing above, which makes sense because grades only go up to 100%. Okay, we're done with the quartiles. Let's move on to the variance and standard deviation. Remember the funds example earlier on where one had higher variability than the other. Both ended up producing the same result, but one varied more throughout the year as the stock was more volatile, and the other one varied less. This is the concept of variability. Let's say with 10 students, the average mark on the exam was 80%. Variation from the mean means how much other marks deviated from the mean, either higher or lower. Taking this a step further, we need to understand the concept of standard deviation. Let's say you are a European economics researcher and present the stock variability from your study in euros. Your colleague in the UK does the exact same study, but he presents the results in pounds. It's hard to see the relationship like that because of the currency differences. So we use a standardized presentation. Instead of saying it varies between plus or minus euros or pounds, we say it varies X standard deviations around the mean. The mean, instead of being, let's say, 80%, it is 0. And any standard deviation from the mean, it is measured in units of standard deviation. That way, one standard deviation is the same for both researchers. So when looking at the standardized graph, you know that 0 is the mean, and the results that deviate from the mean are measured in 1 standard deviation, 2 standard deviations, and so on. You can perform the calculations in the population and in the sample. The formulas are different. Here we'll be focusing on the population. Later on, I'll show you the differences in the sample. It's more important at this point to understand the key concepts now, and later on, start focusing more on some mathematical gimmicks. To calculate variance for a population, this is the formula. It is essentially the data point minus the mean, all squared, divided by the number of elements in the data set. Here, the result is 321. If you have a calculator with variance function, you can do this directly. If not, you can do a table like this and sum all the values. Variance is measured squared. So to get the related to our data points, we find the standard deviation, which is the square root of the variation, giving us 17.92%. This means that on average, grades deviate 17.92% from the mean grade. In other words, 17.92% is one standard deviation that deviates from the mean. So 2 standard deviations, it's 2 times 17.92 and so on. The curve you are seeing here is called a normal curve or Gaussian curve. It is not always centered like this, which brings us to the next set of measures. Measures of shape. Here we are going to look at skewness and kurtosis. Let's start with skewness. A curve can be negatively skewed when it skis to the left. It can be centered or positively skewed when it skis to the right. Notice the mode, median and mean that we have calculated before, but when in a graphical setting. Looking at our graph, we can also see this in a box plot chart with the values we calculated before. notice the outlier. What about kurtosis? Kurtosis is about a tighter or wider dispersion of the graph. If it has a shorter dispersion, it is called leptokurtic. If it has a wider dispersion, it is called platykurtic. And if in the middle, it is called mesokurtic. When applied to a standard normal distribution, we saw the normal curve, an extra key concept here is called excess kurtosis. The excess kurtosis is calculating by subtracting 3 from the kurtosis value. In a normal distribution, the kurtosis is 3, so the excess kurtosis for a normal distribution is 0. Excess kurtosis provides additional information about the shape of the distribution beyond simply indicating whether it is leptokurtic, meaning positive excess kurtosis, or platykurtic, negative excess kurtosis. There are formulas for both skewness and kurtosis. We won't get into it. I just want you to get the idea of these two main measures of shape. This last measure of dispersion, which could be included in a category of its own, it's standard error of the mean. It relates to the sample, not the population, although it's connected. The formula represents when we take a sample from the population, its mean might not represent the true population of the mean, as we are most likely introducing an error. So the standard error of the mean is the calculated error that we include when stating the sample mean. A key word on organizing data and presenting it in graphs. We start off with a data set such as this one. Remember, if you are giving it unordered, you need to order it first, from the lowest value to the highest value. Then you can create what it's called a stem and leaf. It's the same data set but presented in a different way. Notice the 4 stem. It means 40, 46, 47, 47, 49, and when it moves to 50, you keep going within that range. 51, 53, 54, and so on. You'll be frequently asked to do a class interval representation as well. It's similar to a stem and leaf, but it's like a step further. You define an interval width. In this case, each bar will be shown in x intervals of 10. And the frequency is the number of occurrences between 0 and 10. In this first case, 3. So then you can present the information in a graph called histogram. There are other graphs like the one we used before called box plot and many others. But this gives you the basis for the first part of this descriptive statistics course. And that's it for this first presentation on descriptive statistics.